Welcome. Up till now we have seen on-off control, proportional control, integral control and derivative control. Now today we will see proportional plus integral type of controller, that is P+I, proportional plus derivative type of controller, that is P+D, and proportional plus integral plus derivative type of controller, that is P+I+D. Now we will see proportional plus integral type of controller, that is P+I controller. A controller in the forward path which changes the controller output corresponding to the proportional plus integral of error signal is called PI controller. Mathematically, output of controller is equal to Kp into Et plus Kp into integration of e raised to t dt. The important advantage is that 1-to-1 correspondence of P mode is available. I mode, the integral part of such composite control, provides a reset of the zero errors output after a load change occurs. A controller in the forward path consider the load change occurrence at t is equal to t1 and due to which error varies as shown in figure below. Therefore, these two graphs are there. In first graph, on y-axis error, that is et, is there. On x-axis time is there. Now at t1, this is the graph. Now if you project this graph on another graph, that is controller output versus time. Now this is time t1, this is time t2. Therefore, this is Vp, or immediate rise due to proportional action, and this is Vi, rise in output due to integral action between times t1 and t2. Means in here we have calculated output when time changes from t1 to t2. That's why this is known as integral action of time. In above figure, Vi is equal to rise in output due to integral action between times t1 and t2. Vp is equal to immediate rise due to proportional action. Now again another graph is there. On y-axis error, it is there. On x-axis time is there. Now here time is below the zero line. Another graph is there, that is control output versus time. Here time is there. Now this line is known as proportional action. This line is known as integral action, and in between these two lines this inclined line is there. This is known as composite mode. The controller output changes linearly with respect to time at a rate Kp divided by Ti. The reset rate is defined as reciprocal of Ti. The response shown in above figure A is for the direct action of the controller response of composite PI control mode for reverse action is shown in figure B. The sum of P plus I action finally leaves the error to 0. Now next controller, that is proportional plus derivative controller, that is P+D controller. A controller in the forward path which changes the controller output corresponding to proportional plus derivative of error signal is called as proportional plus derivative controller. A series combination of P and D controllers gives P+D control mode. Mathematically, output of controller Pt is equal to Kp into Et plus Kd into d dt of Et plus P of output. The behavior of such PD control to a ramp type of the input is shown in figure A below. Therefore, this is the diagram or graph. On y-axis error signal it is there, on x-axis time is there. This is the ramp or ramp output. This is the slope, that is d dt of Et. Again, if you project this graph on the second graph, there this Vd is there, that is output due to derivative action. Vp output due to proportional action as the time changes from t1 to t2, where Vp is equal to rise in signal due to proportional action between times t1 and t2. Vd is equal to immediate rise due to derivative action. The ramp function of errors occurs at t is equal to t1. The derivative mode causes a step Vd at t1 and proportional mode causes a rise of Vp is equal to Vd at t2. This is for direct action of PD control. The figure B shows the behavior of PD control for the arbitrary load changes for reverse action. Now again here y-axis error signal is error is there, on a x-axis time is there t. This MP is equal to MD up to this point. This is MD is equal to KD into A, and this line indicates MP is equal to KP into AT. Therefore, next controller, that is last controller, proportional plus derivative plus integral controller or 3-mode controller or P+I+D controller. The composite controller including the combination of P, I and D, that is proportional, integral and derivative control modes, is also called as P+I+D control mode, and controller is called as 3-mode controller. Mathematically, output of the controller P of t is equal to, now here addition of outputs of the 3 controllers will be there. It is Pt is equal to Kp into e raised to t, it is for proportional controller, plus Ki into integration of Et dt, it is for integral controller, plus Kd into d dt of Et, it is for derivative controller. This mode has advantages of all the modes. I mode eliminates the offset error of the P mode, and response is also very fast due to D mode. The sudden response is produced due to D mode. Thus, it can be used for any process condition with the PID control action. There is no offset, no oscillations with least setting time, so there is improvement in both transient as well as steady state response. Figure A shows response of PID control mode for particular error signal assuming direct action. Now y-axis error, again x-axis time is there. On y-axis control output, that is P of t is there. On x-axis time is there, therefore this action is known as derivative action up to this. This line indicates integral action and this line indicates proportional action. Therefore this is nothing but P+I+D controller graphs. Figure shows below the response of various control modes to unit step load change. Again on y-axis output is there with respect to time, x-axis time. Now this graph indicates graph without controller. This graph, if from this to again this like this wavy nature or sinusoidal wave, it indicates proportional controller. Again from this to this indicates proportional plus derivative controller. Now again this line indicates proportional plus integral control, and at last this line indicates proportional plus integral plus derivative control. Okay, we will stop here. Chapter is over. Next lecture we will see MCQ test or objective type of test on this chapter. This chapter is only theoretical, no numerical treatment. Thank you very much.